Deep in the heart of Mexico, a quiet revolution is growing in the arid soil. This is the Nopal cactus, a plant that thrives where few others survive. It's spiky, resilient, and surprisingly, the future of fashion. For centuries, this desert plant was just food or a weed. But beneath this tough exterior lies a complex fibrous structure and unique proteins waiting to be unlocked by modern engineering. And this is the result. It looks, feels, and smells like premium leather. It is durable, luxurious, and highly sought after by top global brands. But not a single animal was involved in its creation. How do we get from this spiky plant to this buttery soft material? Today, we're getting exclusive access inside the high-tech facility, transforming this abundant desert weed into the fashion industry's new gold standard.
Beautiful, high-quality vegan leather.
We are about to witness a process that blends ancient agriculture with cutting-edge chemical engineering. It's a high-speed, highly efficient journey from farm to factory floor. Forget toxic tanning and massive water waste. This is a new kind of alchemy. Welcome inside the modern cactus leather factory. The process begins here on a certified organic farm. The most crucial detail? No irrigation. Unlike cotton, which needs vast amounts of water, these nopal cacti are entirely rain-fed, thriving on natural humidity. This farm isn't just saving water, it's actively cleaning the air. These 40 acres act as a massive carbon sink, absorbing over 8,000 tons of CO2 every single year. It's net positive agriculture. Harvesting is a precise operation. Workers select only the mature pads, leaving the main plant alive and intact. This isn't a one-time crop. A single cactus plant will regenerate for 8 years. This selective pruning actually stimulates further growth. Once cut, the pads are rapidly crated and loaded onto transport vehicles, racing against time to retain their internal moisture before processing begins. The farm and the primary processing facility are located right next to each other. This proximity is vital to reduce transport emissions and ensure the nopal arrives fresh for immediate processing. Upon arrival, the nopal pads are immediately offloaded into the intake system. The clock is ticking. The goal now is to stabilize the organic material and stop fermentation. First, a rigorous cleaning cycle. High-pressure water jets remove field dust and any remaining debris. The water used here is captured, filtered, and reused in the next washing cycle to minimize waste. Clean pads are fed into an industrial crusher. This powerful machine breaks down the tough cellular structure of the cactus, maximizing the surface area for the extraction processes to follow. The shredded material is further processed into a fine mash. This releases the plant's natural fibers and distinct proteins, the essential building blocks of the final leather alternative. This vibrant green pulp is heavy with water. Before we can create the leather formulation, we must remove moisture without damaging the valuable polymers inside. Instead of energy-intensive gas ovens, the facility uses a massive passive solar solarium. The pulp is spread thin and moved slowly through these temperature-controlled tunnels for 3 days. The sun does the heavy lifting. Over 72 hours, the moisture evaporates, transforming the wet mash into stable, dried cactus flakes. This passive process saves massive amounts of energy compared to traditional drying methods. The resulting dried flakes are stable, easily stored, and ready for the next crucial phase, the laboratory, where nature meets high-tech chemistry. We leave the farm behind and enter the realm of green chemistry. This is where the proprietary magic happens, transforming a dried plant into a high-performance bio-resin. First, the dried cactus flakes are milled into a micron-fine powder. This increases reactivity and ensures a smooth final finish. The powder undergoes a proprietary extraction process to isolate specific cactus proteins and fibers. These natural polymers provide the strength and elasticity needed to mimic animal hide. The result is this viscous bio-resin. It's important to note, the final leather isn't just a cactus leaf ironed flat. It's a sophisticated composite material. To achieve the required durability, the cactus resin is blended with other non-toxic, bio-based additives and plant oils. This formula is the company's most guarded trade secret. Unlike traditional leather tanning, which often uses toxic chromium, coloring here is achieved with organic, heavy metal-free pigments. The liquid resin can be dyed any color imaginable. Once the formulation passes strict quality checks for viscosity and color consistency, the bio-resin is ready for the main factory line. This is where agriculture meets heavy industry. This coating line is nearly a football field long, designed to run continuously, turning the liquid resin into solid rolls of material. The process starts with a backing material, usually organic cotton or recycled polyester. This provides the structural integrity and tear strength of the final product. The cactus bio-resin is poured onto the fabric. Precision blades ensure the liquid layer is applied with micron-level accuracy, determining the final thickness of the leather. The coated material enters a long curing oven. Controlled heat evaporates the remaining moisture and cross-links the polymers, turning the liquid resin into a solid, flexible skin. It emerges as a smooth, solid sheet. But to truly compete with animal leather, it needs character. It needs texture. This is the transformation point. Massive heated rollers apply immense pressure, stamping a hyper-realistic grain onto the surface. By changing the roller, the factory can mimic anything from soft calfskin to pebbled textures, giving designers endless aesthetic options without the ecological baggage. A final cooling stage sets the texture, and a micro-thin protective top coat is applied for scratch resistance and the desired matte or glossy finish. Before rolling, every inch is scanned by high-speed optical cameras. Unlike cowhide, which has natural scars and imperfections, this material is uniform edge to edge. The result is a high-yield, consistent product that dramatically reduces waste for manufacturers compared to the irregular shapes of animal hides. But does it hold up? To answer skeptics who equate vegan with cheap plastic, every batch is sent to this torture chamber.
The tensile strength reached 500 newtons before failure. Interesting. The abrasion on this yarn is significant after only 10 cycles.
Here, samples are stretched to their breaking point to ensure they meet the rigorous tensile strength standards required for footwear and automotive upholstery. This machine rubs sandpaper against the leather for over 100,000 cycles, simulating years of heavy wear on a car seat or sofa. It must not peel or crack. For footwear, the material must endure millions of flexes without cracking. This material is engineered to last over a decade of daily use. It also undergoes rigorous testing for flammability and chemical safety, ensuring it meets international standards for consumer goods, free from toxic substances. Passed by QC, the rolls are stored here, ready for global distribution. This isn't a niche experiment anymore. It's full-scale industrial production. From this desert facility, these rolls are shipped to ateliers in Milan, Paris, and Tokyo, ending up in the hands of the world's top designers. In the hands of artisans, the material behaves exactly like traditional leather, cutting cleanly and allowing for precise craftsmanship. It sews beautifully, allowing for high-end detailing and durable construction in handbags, shoes, and apparel. Major automotive brands are already adopting it for interiors, drawn by its durability, lightweight, and sustainable credentials. And in fashion, it's proving that you don't need to sacrifice aesthetic luxury to be environmentally responsible. The impact is undeniable. Producing 1 kilogram of animal leather can require over 10,000 liters of water. This process uses barely 2. We often look to complex high-tech to solve climate change, but sometimes the most elegant solutions have been growing in the desert sun all along, just waiting for us to notice.
Holding what it can become truly brings this story full circle.
From mushroom mycelium to pineapple fiber, the materials revolution is just beginning. Which one should we explore next? Let us know in the comments below. Thanks for watching.